Okay, to find the Maclaurin's series for this, first thing I would just find, I'm just going to let fx is equal to all of that expression here. So then f0 is going to be equal to ln 0 plus 2 is 2 plus ln 0 to the square plus 5 is 5, and this, if you use the law of logarithms, you should be able to get ln actually 2 times 5. So this comes to ln 10. Now, having found f0, we're going to have to differentiate the expression now. So we have fx is equal to all of that. So therefore, f prime of x is going to be equal to, if you differentiate ln x plus 2, you should know it should be 1 over x plus 2. And then differentiating this one here is going to plus 2x divided by x squared plus 5. And now if I were to, this is f prime of 0, and substitute 0 in here, I should be able to get 1 over 2, substituting 0 here, 0, so f prime of 0 is basically half. Right, so now what I need is f double prime of 0, so f double prime of x, I can send this upstairs and make it like x plus 2 to the power of negative 1, multiply by negative 1, subtract 1, and so you differentiate this. And then if I were to differentiate this one here, I can use quotient rule, and this is my u and this is my v. So I'm going to say plus v, which is the denominator, so x squared plus 5 times the derivative of the numerator, so that's going to be 2, and then minus u dv by dx, so u is 2x, and the derivative of the denominator is going to be 2x, because if we differentiate this, you're going to get 2x, and all of that over v squared, so that means over x squared plus 5 to the square. So what we have is f double prime of x is equal to negative 1 over x plus 2 and all of that to the square, because if this is minus 2, downstairs becomes positive 2. 2x squared here minus 4x squared here is going to be minus 4x squared. And then 2 times 5 is 10, so 10 minus 4x squared is 2x squared. So minus 4x squared plus 2x squared divided by x squared plus 5 and all of that to the square. Simplifying this further, okay, so this is what we are going to get. So plus 10 minus 2x squared and divided by x squared plus 5 and all of that to the square. So now we're very comfortable with this. We're going to just put 0 in here. So f double prime of 0 is going to be equal to, if you put 0 here, it's going to become minus 1 over 0 plus 2 is 2, 2 to the square is 4. So negative 1/4 plus, and then if here I've got 0, so 0 times 0 to the square, 0 times 2 is 0, 10 minus this is 10, divided by 0 plus 5, and then 5 to the square is 25. So I have then 10 over 25 minus 1/4. If you do this on the calculator, you should be able to get 3 over 20. Now we're going to use the Maclaurin's series. So we have then f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial. So using this, I go up to the term including x squared. So now this is going to become f0, which is ln 10. We found this earlier, plus the half of x, because this is half here. We got x with it. F double prime of 0 is 3 over 20. So I'm going to say plus 3 over 20 times 2 factorials times x squared. And finally, if I were to simplify this, I end up with this expression here, plus then 3 over 40 x squared. And here we are. That's the Maclaurin series of this expression up to the term including x squared. Take care.